I gave you sucrose, C12H22O11.
Freak out.
Oh, you would not cry.
Multiply the things by.
We take 12 atoms of carbon times its mass and add that to 22 times the mass of hydrogen and add that to 11 times the mass of oxygen, and we get 348-ish. Probably ran out of word room there. Okay. So molar mass, just adding up the masses of all. We did this with fasteners and rings when we asked you for formula mass of FSR. Okay, and formula mass of FSR2, FSR3. We just added the masses of the fasteners and the rings together. 35. Aha! The rest are the math problems. How to calculate mass when you're given number of atoms. So, if I say that you have 1.5 times 10 to the 24th atoms of carbon. What is the mass of that? What would you do?
That number times 1 mole over.
Times 1 mole over. No. This is atoms. I want to know the mass. 6.02 times 10 to the 23rd atoms. And then what? I still want to find mass. Is this what you did in the last few problems on the bean lab? Yeah.
You put 12.011 over 1 mole.
12.01115 grams of carbon over 1 mole. Okay, so this is this problem with 2 conversion factors. We're turning our atoms into moles by dividing by Avogadro's number. And then we're turning our moles into grams by multiplying by the molecular mass, or atomic mass. Okay, the chart on the bottom of the bean lab that has the mole picture in the middle and the balance on one side and the particles on the other, that's what we're doing here. Is that all in the view on the camera?
Yeah.
Or am I chopping it off? Okay. Make sure everybody can see that. Let's see. 36. How to calculate mass when given the number of moles. Well, that's a shorter problem. If I tell you you have 27 moles of carbon, how do you find the mass of that? What do you do? What's our conversion?
Times
12.01115, and we're getting that from the periodic table. Grams of carbon is 1 mole, right? Can you see that that's just this conversion factor out of this problem? We just didn't have that other step. So 27 times 12 divided by 1, whatever that is, will give you your mass of carbon. Okay? So this problem is actually more involved than this one. But the math, you're either multiplying or dividing by atomic mass, or multiplying or dividing by Avogadro's number in all of these. 37, how to calculate moles when given the number of particles. Okay? That is really, in this problem, it's that part of it. You have the number of particles, atoms, molecules, ions, pickles, people, eggs, chickens, puppies, whatever. Okay? The mole of anything, however many anythings you have, divided by Avogadro's number. That's the conversion right here that lets you convert from particles to moles. Okay? If you can do this whole problem, you know all the parts to doing the other kinds. 38. How to calculate mass when given moles. Well, that's this one again. Or did I backtrack?
No.
38 is that one again. 39, how to calculate mass when given number of atoms. That is another problem like this first one. You have atoms, you're dividing by Avogadro's number to turn it into moles, then you're multiplying by the atomic mass to get grams, mass in grams. Okay? What if it was for a compound instead of an element? Then what would you multiply by?
The mass.
The mass of the compound, the molar mass of the compound. And how would you get that? You'd add the parts up. Good. And number 40, how to calculate the number of atoms when given mass. That is the exact opposite of this example. Okay? So maybe we start with, I don't know, 25.0 grams of sodium. And I want to know how many atoms is that? Well, we always have to go to moles first. Mole is the stepping stone between particles and grams. So, how do we cancel grams on the bottom and turn it into moles? Divide by molar mass. 1 mole is 22.98987 grams for sodium. Okay? But we're not done there. Then we want to turn that into particles. Well, or atoms. What conversion lets us compare moles of sodium to atoms of sodium? Where does the 6.02 go? Top. 6.02 times 10 to the 23rd atoms is 1 mole. Please notice what number I have attached to the word mole in these conversion factors.
1.
The number 1. Okay? The number 1 is attached to the word mole. Because a conversion factor lets us compare something to 1 or 1 to something. A lot of times I see people trying to put Avogadro's number in there right away, and you might not need it in the problem. Okay? So the conversion factor should have the number 1 in it, and 1 should be attached to mole. If we have more moles than that, we'd have our problem starting that way. Okay, and that covers test hints 21 through 40. Good job. Whew, the other class didn't clap, so.